You're listening to the Bare Metal Cyber Prepcast, created to help you succeed in your Cloud Plus certification journey. Learn more at baremetalcyber.com, where additional prepcasts, books, and training materials await. Let's get started. Databases form the core of most applications and services in cloud environments, powering everything from dynamic content delivery to secure transaction processing. Migrating these databases is a critical part of cloud adoption, whether moving from on-premises systems to the cloud, between providers, or changing architectures. Database migration involves more than simply copying data. It requires attention to schema design, data consistency, network performance, and platform compatibility. In this episode, we examine both relational and non-relational database migration strategies to help Cloud Plus candidates prepare for real-world tasks and exam scenarios. The Cloud Plus exam includes topics related to the movement and optimization of database systems, with emphasis on choosing the correct migration path based on database model and platform. Candidates are expected to understand how relational and non-relational databases behave differently, and how these behaviors influence migration planning. Familiarity with data export, replication, indexing, and platform-specific tools will help candidates assess options and troubleshoot problems during migration. Relational databases follow a structured schema and use the structured query language for interaction. They store data in tables, where relationships between rows and columns are enforced by constraints and indexes. Examples include MySQL, Microsoft SQL Server, and Postgres. These databases are common in transactional systems where data integrity, normalization, and complex querying are required. Migrating a relational database typically means moving not only the data but also the schema, indexes, stored procedures, and access control definitions. Non-relational databases, also known as NoSQL databases, store data in flexible formats such as key-value pairs, JSON documents, column families, or graph relationships. These databases are designed for unstructured or semi-structured data and include examples such as MongoDB, Cassandra, and Amazon DynamoDB. Because non-relational systems do not rely on fixed schemas, they provide greater agility and scalability, but often require different strategies for data validation and query performance during migration. Relational database migrations often begin by exporting the schema and data using SQL dump tools, replication systems, or managed export services. The target system must be provisioned with an identical or compatible schema. After data is imported, administrators test sample queries, constraints, and indexes to confirm that the system behaves identically to the original. Integrity checks, foreign key validation, and transaction handling must be confirmed to avoid future failures. Migrating a non-relational database typically involves exporting collections or records using platform-native tools or APIs. Data is transferred using batch import jobs, change streams, or continuous replication agents. In addition to the raw data, administrators must reconfigure secondary indexes, replication settings, and sharding strategies in the destination system. Unlike relational systems, validation often occurs at the application level, making test coverage an essential part of post-migration verification. Whether relational or non-relational, schema compatibility is a primary consideration during migration. Relational models require that the source and target databases match field types, constraints, and index definitions. Non-relational databases may not enforce strict schemas, but indexing and access patterns must still be compatible. Schema conversion tools can help translate between dialects, such as from MySQL to PostgreSQL, or from MongoDB to DynamoDB, depending on the migration direction and feature set. Large datasets require special handling during migration. Migrating terabytes of information in a single session may overwhelm bandwidth, time windows, or storage buffers. In such cases, chunking the data into smaller units, throttling import jobs, or using incremental synchronization helps maintain system responsiveness. Cloud settings such as storage tier, IOPS limits, and memory buffers should be configured to ensure smooth ingestion during each phase of the migration. Network optimization also plays a critical role in database migration success. Cloud providers may offer dedicated network links or high-speed migration services to accelerate data movement. Encryption should be enabled to protect sensitive data in transit, and compression reduces transfer size, lowering cost and speeding up operations. When multiple regions or availability zones are involved, replication delays and retry mechanisms must be accounted for in the migration timeline. High availability is essential during migration planning. Techniques such as continuous replication or database shadowing allow the new system to synchronize with the old one in near real time. Once ready, a cutover event switches the application to the new system. This approach minimizes downtime and supports rollback in case of failure. Monitoring replication lag, warming up caches, and validating the consistency of real-time updates are all crucial tasks during this process. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. Backup procedures must be a core part of any database migration plan. Before initiating a migration, administrators should create full logical or physical backups to preserve system state. Logical backups may include exported SQL files or document archives, while physical backups involve snapshots of volumes or file systems. After the migration, restore operations must be tested in the new environment to confirm that disaster recovery tools work as intended. Many cloud providers offer native snapshot functionality, which helps preserve database states and supports rapid rollback in case of failure. Validation is essential after any database has been migrated. This involves comparing table structures, verifying record counts, and executing known queries to confirm that the data has been transferred accurately. Benchmarks should also be run to evaluate performance characteristics under load. If indexes or query plans have changed, performance anomalies may appear even if the data is intact. User permissions and roles must also be reviewed to ensure access controls were properly recreated in the destination environment. Licensing considerations often affect both planning and execution of database migrations. Proprietary database engines may have restrictive licensing that limits which platforms they can run on or how many instances can operate simultaneously. When switching to a cloud-managed database service, licensing may be bundled into the subscription, but feature sets can differ. Incompatibilities may appear if legacy features are not supported in the cloud version. Budgeting must also account for support levels, high availability options, and regional pricing differences. To streamline migrations, cloud vendors offer migration utilities such as Database Migration Service or Replication Managers. These tools help automate schema copying, data transfer, and synchronization tasks across heterogeneous environments. Third-party tools may be preferred for hybrid or cross-cloud migrations that span on-premises and public platforms. Selecting the right tool depends on the database model, size, tolerance for downtime, and compatibility with source and target systems. In some cases, a database migration may involve more than simply moving data. Refactoring refers to changing the schema or data structure to align with a new application design or cloud-native approach. Replatforming occurs when the underlying database engine changes but the data model remains consistent. These transitions are more complex but are sometimes necessary to eliminate licensing constraints, improve scalability, or integrate better with new application layers. Cloud Plus candidates must know how to distinguish these strategies during exam scenarios. Performance tuning after migration ensures the new environment is fully optimized. Indexes, buffer sizes, and query execution plans should be reviewed and adjusted to match the performance characteristics of the new platform. Cloud-specific factors like IOPS limits, memory allocation, or network latency may introduce new bottlenecks. Continuous monitoring helps detect slow queries, lock contention, or capacity issues early, ensuring stable and responsive operations post-migration. Security settings must be carefully reapplied after a database migration. This includes encryption at rest, encryption in transit, user authentication policies, and audit logging. Compliance frameworks such as HIPAA, PCI-DSS, or GDPR may require updated documentation, retention policies, or log formats. Backup systems should include security configurations, and new access logs must be validated to ensure that alerts and reports still meet policy requirements. Even with the best planning, database migrations can encounter pitfalls. Common problems include data truncation due to mismatched column types, encoding errors caused by differing character sets, or missing indexes that degrade performance. Diagnostic tools, error logs, and comparison scripts help identify the root cause of these issues. A rollback strategy, including prior backups and reversion timelines, must always be in place to minimize service disruption and protect data integrity. To summarize, migrating relational and non-relational databases in the cloud requires a thorough understanding of schema models, data formats, network performance, and tooling. Whether refactoring or replatforming, the migration must be validated with backups, performance tests, and access control checks. Cloud Plus candidates must be ready to assess database architectures, select the appropriate migration path, and troubleshoot configuration issues across a variety of cloud platforms. Thanks for tuning in to the Bare Metal Cyber Prepcast, your trusted source for cybersecurity news and insights. Remember to subscribe at baremetalcyber.com so you never miss an update. And visit cyberauthor.me for best-selling cybersecurity books that equip you with expert knowledge. Until next time, stay secure and stay vigilant.